Hi viewers, continuing with our series on permutations and combinations, today's is the second lesson and we are going to talk about permutations. What do we understand with the word permutations? Permutations word is nothing but arrangements, the ways in which given objects either taken all or some at a time can be arranged. The formal way one can define the word permutations would be a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. Now, what we are interested in is finding how many permutations can be done. That means, in how many ways certain objects taken all or few may be arranged, and that is where we come up with a certain result which is specific to permutations when all the objects are distinct. And in our next lesson we may look at the other possibility when objects are not distinct. So, when permutations have to be figured out for objects which are all distinct, there is a result, and the result says that the number of permutations of n different objects taken r at a time, where r is greater than 0, but less than equal to n, and the objects do not repeat, is given by this product, that is n minus 1 times n minus 2 up to n minus r plus 1, and also has a notation. We denote this quantity, this number of ways, as NPR. It is read as NPR, written exactly the way you see it. Some of the authors also prefer to write it as P and then bracket n comma r. We will be using this notation of permutations of n objects taken r at a time. Now, where is this result coming from? A quick look at that. We are looking at arranging n different objects taken r at a time. So, I can think of it as r places to be filled by n objects. And so, if I start with the first place, I have n ways of filling it up. The second place can be filled in n minus 1 ways. This result is about cases where objects do not repeat. So, if there are n objects and one of them has taken the first position, we are left with n minus 1 objects that can now take the position second. Similarly, the third position can be filled in n minus 2, because 2 objects have already been used up in first and second place. So, how many now are left for us to occupy the rth place? Think about it carefully. You have r places, out of which r minus 1 places have already been filled up. That means, out of n objects, r minus 1 have already been used. So, how many are left now for the rth place? Yes, it will be n minus r minus 1 within the bracket, same as n minus r plus 1. So, there are r places, and starting from the first to rth, they can be filled in n minus 1, n minus 2 up to n minus r plus 1 ways, or n minus within the bracket r minus 1 ways. And therefore, the principle of counting, which told us that if there are 2 or more events that can be done in m and n ways, then the number of ways they can be simultaneously done will be m times n, tells us that the total number of permutations in which r places can be filled by n objects is this continuous product n into n minus 1 into n minus 2 up to n minus r plus 1. And this is what we have defined as NPR. So, NPR becomes this product. Now, if you think about this product, there is a way in which we can now make it much more compact, because we have already talked about the notation of factorial in our earlier lesson. And so, what you seen is, if I look at n into n minus 1 into n minus 2 up to n minus r plus 1, and I multiply and divide by n minus r factorial, then there is a possibility to look at the numerator again and see that we are looking at a continuous product starting from n to 1, and therefore, the entire numerator combines down to be nothing but n factorial, and that there is now the result that we will be using again and again. That is, the number of permutations of n different objects taken r at a time, denoted by NPR, is equal to n factorial divided by n minus r factorial. So, if I have 5 objects and I am using only 3 to make an arrangement of 3 places, then the total number of ways it can be done will be 5p3, which will be 5 factorial divided by 2 factorial, that can be simplified. So, I hope this formula is now clear to all of you, and we are ready to take a problem based on it. How many different signals can be given using any number of flags from 5 flags of different colors? Now, we are making signals from 5 flags of different colors. So, I may choose 1 or 2 or 3 or 4 or all 5 flags to create that signal. Creating a signal is nothing but making an arrangement. So, if I want to create a signal using 2 of the 5 flags, it will be the arrangement of those 2 different flags that we are making use of. And therefore, the number of signals that can be made with one flag equals nothing but the number of ways 1 out of 5 object can be permutated, which happens to be nothing but 5p1. Similarly, the number of signals that can be made with 2 flags will be the arrangement that can be created taking 2 of the 5 given flags, same as 5p2. Similarly, we have 5p3, 5p4 and 5p5. If we calculate each one of them, you will be able to find the total number of signals. But the total number of signals as entirely in this form would be the sum of all these possibilities, because we are making a signal either with 1 flag or 2 or 3 or 4 or 5. So, there is an addition theorem that is now getting involved here. These ways are not to be multiplied. They are in language of addition, following the principle which says that the flags, either 1 flag or 2 or 3 or 4 or 5 are taken, and therefore, the total number of signals that can be formed by using any number of flags turn out to be a calculation coming out from this. 5p2, if you care to look, will be nothing but 5 factorial by 3 factorial, which would simplify to be 5 times 4, and similarly for the other, and the total number that comes out is 325. Another interesting problem here: how many words with or without meaning can be formed by using the letters of the word triangle? How many of these words start with T and end in E? So, 2 things to be figured out. How many words with or without meaning that can be formed using the letters of the word triangle? So, we are looking at how many letters are there in the word triangle first. 8 letters. Now, these 8 letters have to be permutated. The word may not have a meaning, but the arrangement of 8 letters in 8 places, that is nothing but the total number of 8 places that can be filled with 8 letters is 8p8. That is nothing but 8 factorial divided by 0 factorial. And remember, we said that we define 0 factorial to be 1 in our earlier lesson, and therefore, 8p8 is nothing but 8 factorial, which turns out to be nothing but 40,312. 20 ways. So, you are able to get that many words formed out of the letters of the word triangle. The second part says how many of these words start with T and end in E. So, now there is a condition. We are looking at the first place must be T and the second must be E. That means this arrangement is not going to change. The arrangement has to be made only for the 6 places between T and E, and that can be done by the 6 letters that are available in 6 factorial ways, because 6p6 is nothing but 6 factorial, which turns out to be 720. So, the total number of words with or without meaning that can be formed using the letters of the word triangle starting with T and ending in E is 6 factorial. Now, just let us extend this possibility. Suppose T and E can be interchanged, then how many total words can be formed? Well, yes, T and E too can be permutated in 2 factorial ways, 2p2, 2 factorial. So, the total number of words that can be formed will become 720 into 2 using fundamental principle of counting. So, more conditions coming in means more thought to be put into dealing with a problem. Let us consider another interesting problem which has a condition on seating of boys and girls. The problem says that in how many ways 6 boys and 4 girls can be seated in a row so that no 2 girls are together. So, there is a condition on girls, but we have 6 boys which can take any of these 6 places. Now, let us see what will happen if we are looking at arrangement for girls. The girls may take, that is these 4 girls may take any of these places that are coming up, that is meeting the condition that no 2 girls are together. So, there are now 7 places here, but only 4 girls available. So, these out of these 7 places, some of them will not be occupied, which means the 2 boys may be together, but the 4 girls to be seated so that no 2 girls are together. Now, we have 7 possibilities. So, starting with the arrangement of boys, 6 boys can be seated in a row in 6p6, that is 6 factorial ways. 4 girls, we have now 7 places, but we have only 4 girls. Therefore, the number of ways they can be seated so that no 2 girls are together is 7p4, number of permutation of 7 objects taken 4 at a time. So, on calculating this product, you get the total number of ways in which 6 boys and 4 girls can be seated with the condition that no 2 girls are together. So, the conditions have to be understood, kept in mind, but at the back you also have to keep the fundamental principle of counting in use. Ready for another problem? Here it is. How many permutations can be formed by the letters of the word article when all vowels come together, and part 2, all vowels do not come together? Now, this is a very conventional problem that you would find in your books and a problem which is very often tested as well. The word article, how many vowels are there? A, I and E are the 3 vowels, and there are 4 consonants T, R, C and L. In our first part, we have to figure out the number of permutations when all vowels come together. In a situation like this, when you want certain objects to stay together, you may consider them as a group, a bundle of objects taken together. So, now I have got A, I and E all tied up together as one piece, and now I have to arrange this one piece with 4 other letters. I am sure you can understand now that we are looking at the total number of arrangements of the group and 4 consonants, that is 5 objects which can be done in 5 factorial ways. But what about the arrangement within this group? I can always have a possibility of writing the 3 vowels in different ways. So, this A, I, E can be permutated within the group in 3p3, that is 3 factorial ways, that is 6 ways. And the number of ways in which this group of vowels and 4 consonants can be arranged was 5 factorial. So, by fundamental principle of counting, the number of words that can be formed with the letters of the word article when all vowels come together will be 3 factorial times 5 factorial, same as 720. Let us take our second part, which required us to find the number of ways in which the vowels do not come together. So, we have already calculated the number of ways in which the vowels are staying together. At the same time, if I have the 3 vowels and 4 consonants, that is the 7 letters, they can be permutated in 7 factorial ways, that is the total number of arrangement possible. From here, if I subtract the number of ways in which the vowels stay together, that is 7 factorial minus 720, then the answer, that is 4320, is the number of ways in which the words can be formed by the letters of the word article when the vowels do not come together. This is one of the possibilities that we need to consider and practice. But then what happens if the word itself has letters which are repeated? For example, the same discussion for a word like mathematics, where you find the word with letters repeating. That will be in our next lesson. Stay tuned.